let's add some input code, because we have talked about the most basic things about setting up a C++ class and how to then connect that up to making up blueprints and how to put that into the world, all that kind of stuff, how to add components to your classes. But now let's make some actual gameplay, because we have this template here in which we can click around, have a point and click movement system, but that's not what we want. I just make this as a template project because it's the closest to what we're actually going to end up using in the end. But this is not what we want. So what we want is we want to move around with WASD. And those don't do anything in this case. So let's open up the code that we already have pre-generated, see how that is built up and how we can change and add to that to make what we actually want. If you come over to whatever your project is in VS Code or whatever IDE you use, you want to look for your player controller. You can also put this code directly on your player character. It really works either way. Player controllers are meant to do this kind of stuff. This will take your input and pass it through to the pawn that you are possessing, which will be your player character. And this way you can very easily switch between characters you're controlling, because all of the input is getting registered through the controller rather than directly on the player itself. For some type of games, especially since we're making a twin stick shooter, maybe you want to have multiple unlockable characters, and maybe at some point we decide actually maybe we want to have a ability to switch between characters, right? Maybe we want to make a Mario Odyssey type mechanic where we can capture other enemies. At that point, it's literally as easy as just saying, okay, now we are possessing that one, and all of our movement code is on our player controller. So we don't have to add that same code to a million different classes. So that's why we use player controller. Anyway, once you have that player controller, you're going to want to make a function called setUpInputComponent. We'll talk more about virtual and override methods later, but it's important that it's this exact name, because this is overriding a function that exists on the parent of this class. Again, we'll talk a little bit more about that later, but if you get what that means, you'll understand why it's important to give it this exact name. For now, just give it this exact name with this exact capitalization and we'll move on. We have the super setup input component. I do believe we talked about that last time. This just means that everything that's in the parent version of this function will run first. And then we can set up our input bindings. And here is where we're going to make our things move. Because right now it's setting up the mouse input events, which we have an enhanced input component, which is a component that exists on the player controller, which we'll talk about in a minute. That has a function called bind action. That takes in a input action, which is an asset that we can make in the engine. It takes in a event type, whether we started this input action. So for a left mouse click, for instance, whether or not we pressed it down or stop pressing it or whatever. Then it takes in a object that is pretty much always just going to be this. And this just means, well, this object. So if you're in the world and you have 20 different instances of a controller, for instance, if you're doing a multiplayer game, this is just a keyword that means that whenever an instance of this class executes this code, it will just refer to itself and not to any of the other instances of it that exist within the world, or any other object for that matter. And then we have a address of. Remember this from the pointer video. This will give you an address of something, a memory address. And then we have a function name with a class. So what this will do is when we start this input action, this object will run this function. Make sense? No? If it doesn't, go back, pause for a moment, think about it, re-listen to what I just said, because this is very important. Because this we're not going to actually use. We're going to put in our own bind actions. But for that, we're going to need to make our functions that we're going to run when those actions are done first. So let's comment away all of this code here. Just so that it doesn't run anymore, and do the same thing here. If you're using VS Code, by the way, that is Alt, Shift and A will comment out all your selected code just like that. It's a very handy little thing. And if you then do that same shortcut, it will uncomment that code again. That will save you a lot of heartache going forward. Do remember. I could just delete it, but this is the wonderful thing about working with traditional code, is you can just comment something out if you're not sure whether or not you're going to use it in the future. Let's make our function. we're going to make a function to just move us around. Just very simple, and we'll worry about animation and stuff later. That's mostly going to be separate from using C++ anyway. So find the corresponding header file, and here we're going to make in our either in protected or private. I'm going to do it in private now because I don't think we're going to make children of this anyway. So protected probably doesn't even matter that much. Let's just do it in protected anyway. I don't really care. We want to make a function called void, and we'll just call this move. This one you can call really whatever the hell you want, because we're not overriding anything. This is just, we're going to be using this function to move around. In that, we'll need a f input action value, and that will take in the memory address of a value. If you keep getting an error here that it's an undefined type or whatever, scroll up to the very top of your header file and see if you have the line #include input action value.h. We'll get a little bit more into includes and header files in maybe the next video or the video after that. Let's create a definition for that. And now we can start coding this actual function. So we're going to need to get a couple of things. First and foremost, we're going to need to get a f vector 2D out of this, and we'll call this the movement vector. We'll set that equal to whatever this value is. This input action value can have a bunch of different types of data in it. It can have a bool in it if it's just a simple button, like the X button. Is the X button being pressed currently? If we map that to it, this input action value can be used to get a bool out of it. But we're going to map this to an analog stick, which means that we're going to get a vector 2 out of it, or a vector 2D, something with an X and a Y value. How far in the X value do we have our analog stick tilted, and how far in the Y value do we have it tilted? So we can simply say we want to use our value and get something out of that, but now we still don't know what to get out of it, and we'll also get a error here, and that is because this is a template function, and in a template function, I think we've used one before, you need to put these little brackets in there, those little pointy brackets, and here you put the type that you want to use with this function. So if we want to get a bool out of this, we put in a bool here, and that will work perfectly fine most of the time. For our purposes, we want to get a vector 2D out of this. So now we have this vector 2D here, which is going to get set to whatever our movement input is. Then we need to add it to the actual character in a movement, because we have a value, how and where we need to move now, but that's just a directional input. We don't have a speed, we don't have anything to tell the character to actually use that to move, so let's do that. We can do that with a function called getPawn. If you're doing this directly on your character, you don't need to do this because you're already on a character, which is a pawn, so you have direct access to this function that I'm going to use. But if you're on your controller, like I am, you want to get pawn, which gets you a pointer to the pawn that you're currently possessing, and then we want to add movement input. This function takes in a couple of things, like the world direction. Hey, we just made a variable for a direction. We can just simply put that in. We want to have a float for the scale value, and this is just a overcomplicated way of saying the speed at which we're going to be moving. So let's make a U property value for that. So that's just simply going to be a float called speed, and we will allow that to be edited anywhere, just for ease of use. So now we can put in speed there, and then the last parameter, it's a bool that decides whether or not your input should be added to your movement, regardless of a other bool that exists on your pawn called is movement input ignored. Well, that's pretty self-explanatory. Usually when that is set to true, it will ignore any inputs that you're giving. You can overwrite that with this function and say, no, just bypass that completely. I always, whatever is the case, want this movement input to be added. For our purposes, it's not going to be relevant either way, but we're going to set that to false. Now, we have a little bit of an issue because Unreal is a mainly 3D engine. You can make 2D games in it, but things like this add movement input, it expects a F vector, which is a vector with 3 axes to it, an X, Y, and a Z. And we just put in a vector 2D. So how can we fix that? Well, let's make a F vector and let's call that input vector, and that will be equal a f vector here. So we can pass in that vector 2D that we just made and just add a 0 to the end of it. And that's pretty much all we have to do there. So now we can put in that input vector here and it should stop complaining. And there we go. And it's as easy as that. This is how easily we can introduce movement. So this is the movement function. We still haven't bound it to anything. We're going to do that in a moment. First, let's go back to the header file for our controller and look for the input mappings here. So we have some class. We'll get to that. That's forward declaration. Also, probably in the next video. input mapping context. And then we have these input actions, both of which are pointers. You're going to need to add both of these into your own class as well. So you're only going to ever need one of these. This is more or less just a list of the input actions that you're going to be using. And for every new input action that you need, so every new button that needs to do something on your character or whatever, you want to add a new input action. So we have set click destination here and set touch destination. For this template, it's also implementing touch screen, which we will not be doing. And we will be making our own real quick here. So let's just copy over everything about this property, add it anywhere, blueprint read only, category is input, the meta is allow private access true. I didn't cover all this in the property video, and that is because by and large, it doesn't matter. You can read up on it on the documentation and it should be pretty straightforward. The only thing that might throw you for a bit of a loop is this whole meta thing, but honestly, I don't really care too much about any of that. And let's call this movement inputs. And now we have a input action called movement input. So let's bind something to that. Going back to our CPP file, I'm just going to simply copy over one of these lines again, because why would I write something that's already written for me? We'll use our enhanced input component, which should be as easy as just doing what happens here, which is an if statement first, just to make sure that nothing crashes. You make a enhanced input component pointer, calling that something like enhanced input component. You can call it whatever you want. And you do a cast checked to the type enhanced input component, and then you pass in the input component variable, which is a variable that pre-exists on the actor class. And with any new Unreal project, unless you upgrade from Unreal 4 to 5, you might need to manually put some settings somewhere in your project, which I don't know off the top of my head. But otherwise, this should by default always just be an enhanced input component as it is. And we can use the bind action, and we will not use the set click destination. We'll use the movement input here. And we will change that from triggered to, let's see what the options are. I think we want to use ongoing here because we want to continuously be moving around. And then on this object, we're going to be running the move function. And when making this function, you want to make this parameter const, which means constant, and that just tells the engine that, hey, this value we're only going to be reading. We're not going to be writing to it. We're not going to be changing the value of whatever this is. And usually that goes very well together with functions like this, where we just want to take in a piece of information, do something with it, but not change it. This is just a little bit of protection that you can build in. And for some functions, it expects a const value to go in. And now that we have set that to a const value, you can see any errors that we might have had before, which I did have an error, is entirely gone. So that is how important it can be to implement that where it needs to go. Now, you might say, hey, wait a second, we had a parameter on this function and we're not passing anything through like that. How does that work? And that is because we're using this bind action. Bind action can run functions without a parameter, no problem. As you can see here, we have the set on destination released, for instance, doesn't have any parameters. It can run that without a problem. It can also specifically run functions with a const f input action value reference that we have here. So it just automatically does that for us, which is very, very nice indeed. So let's actually finally remove all of this code here, because I honestly am just getting annoyed by it. And while we're at it, we're also going to be removing the set destination and set touch destination here, because we won't be using that anymore either. The same thing with the FX cursor. We're not going to be using that anymore either. And short threshold press, we're not going to use any of this, which makes this header file a lot easier to manage, really. We also don't need the bottom two here or the cached destination, so we don't need anything in the private section is really what we're getting at here. Which means we also don't need any of these functions because we will not be using all the input that has been pre-set up. Meaning that these functions here, and I'm actually going to zoom out for this a little bit because otherwise this will be annoying. We can collapse this, we can collapse this, we can collapse that, and we can delete all of that. And we can also delete that. And then on destination triggered, I almost skipped over that, but guess what? We can delete that as well. And now our whole class fits more or less on one screen again, which is quite nice. We don't need a mouse cursor either, meaning that we don't need this constructor at all for the time being. And look at that, it all fits within one screen again. So now we can zoom in again so you guys can actually read what the hell I'm doing. Now that we have that all cleaned up, let's press Alt Control F11 for live coding. You can see I was troubleshooting the fact that I didn't have the const in there a moment ago. Sometimes it throws me for a loop too, guys. It happens. And let's go into our project settings and look for our game mode. Our default game mode is the CPP Tutorial Basics. If we look at where that is in our project, we only have a C++ class of that, and that's quite annoying. So let's make a blueprint class of type all classes, and let's make one of CPP Tutorial Basics Game Mode. We'll call this BPGM Blueprint Game Mode CPP Basic. This is all pretty basic Unreal stuff, so let's go through this relatively quickly. Opening up that blueprint, which apparently opened up on my second monitor. We can on the right hand side see all of our defaults for this game mode, and we want to change our player controller class, which we might not actually need to change that. We have a BP top-down player controller class. Let's see what the parent class for this is. Is that already what we... CPP Basics player controller. I think that's already the player controller that we just were working on. So let's take a look. Yeah, it is. So we have our default mapping input context, which is an asset that we'll take a look at in a moment. And then we have movement input, which is also going to be an asset. There is 2 assets of that type already made. We'll make a new one in a sec. And then we also somewhere in here should have a speed variable. So let's put that to something like 10. I don't know if that's very slow or it's going to be very fast. We're going to find out. Let's look up the location of the default mapping context and open up that asset. We can see it has mappings. It has 2 mappings here. The click and the touch. We're going to be removing both of those. And we're going to be adding our own. And there we can put in these input action assets, which let's make one of those. So in here we have actions. For now I'm just going to simply duplicate it and call this input action movement. You can also make them through miscellaneous and then data assets, and then you have them here in input actions. Let's open up the input action, and here we can see whether or not it should consume the input. Should this action swallow any inputs bound to it or allow them to pass through to affect lower priority bound actions? That makes any sense to you, congratulations. If it doesn't, don't worry. Trigger when paused. So when the game is paused, should we still be moving around? We definitely should not. Reverse all mappings, and then we get the value type. Remember, the value type that we are using here is a vector 2D, because we're going to be using a analog stick, or might as well use WASD. Then triggers and modifiers we don't need to worry about. With that one made, we can put in our new input action in our mapping context, which we just opened up, so that it knows that whatever we're doing here, it has these settings, and most importantly, has this value type. And then we can add inputs to that. So let's add 2 inputs here, or actually let's add 4 inputs, and that is going to be A, S, D, and W. So let's get back to WASD in a moment, and first add gamepad support, because that is ridiculously easy. Anything you need to do there is add yet another input here and look up gamepad left thumbstick 2D axis. This will just pass through the vector 2D that corresponds to your thumbstick input. It's just as easy as that. You can add some modifiers to this, such as for a thumbstick, it's usually a good idea to implement a dead zone, meaning that it can't go over or under a certain value, which 0.2 and 1 are pretty good deals with that. And then what you can also do is adding a scalar modifier here, and that will allow you to put in something like a base speed. We made that speed variable, and we can change that around if we want to, but this will kind of set a base for the speed. So if we say 50, 50, and 1, because we're only using the X and Y components here, that will give us a base speed of 50. And then when we use that speed setup, I think we set it to 10 before, it will be 10 times this rather than 10 times 1, 1, 1. So for any reason, maybe you want your character to move quicker in the X direction than the Y direction, you can best set that up in here. Now, let's get to WASD, because that is a bit more of a nightmare to set up compared to how easy this is. But if you just want to control a game and you don't want to bother with keyboard and mouse, this is all you need to do. Now, these are just normal keys, which is, for the purpose of the engine, the exact same as pressing the X button on a controller or the Y button on a controller or whatever. It's just a bool value, so 0 or 1. And it's going to put that value into the X component of our vector 2D, because it's just going to take that bool value, which is true or false, but we're putting it into something that has to hold a number. So it's going to turn it into a 0 or 1, and we're going to put it into something that can house 2 numbers. So if we don't say anything about what we should do with it, it's just going to put it in the first place that is available, which is the X component. For the A, that's actually quite fine, because the A and the D are about the X horizontal movement. But the A should move us in the negative direction. So we want to add a modifier to it, and we want to say negate, which just makes it negative. You can also say is player mappable. So if you want your player to be able to remap their keys, we're not going to get into that right now, but this is how you enable that, and that opens up player mappable options, and there's again a bunch of stuff that we're not going to get into right now. Then moving on to the S, this is a up and down direction, so we want to put this into the Y component of our vector. And it's also the downward Y, so it's the downward Y. Obviously, we're going to need to, in the modifiers, add a negation, but is still going to just stuff it in the X component. We don't really want that. So what we want to do is add a second modifier, and we'll use the swivel input axis value. And this is just a modifier that tells the engine, hey, this input is going to go into the Y component. And from there, you should be able to quite easily do the D and the W, because the D doesn't actually need any modifiers. The D is just positive X by default. Pressing down D will return a value of 1, and it will stuff it into the X component. So we don't actually need to do anything for the D. For the W, we need to not negate it because it's a positive movement direction. We're moving in the positive Y direction, but we do need to add a modifier for the swivel input axis values, meaning that we are going to use that for the Y movement. And now that we have all of that put in, if you need to go back and rewatch all that, do feel free to. It's quite a bit to wrap your head around. But now that we have all of that set up, and we make sure in our project settings that the game mode we just made is the game mode that we will be using by default, and we go back into our player controller and finally add the movement input action to our little array here, that should now allow us to move around. And I did actually end up messing up the directions, it seems like, and that is mostly because we have our camera set up incorrectly. So the easiest way to fix that really is just to go back into our BP player, and since we made an entirely new class, we have to add in a camera and a camera boom because we didn't do that by default. So let's take a look at where that is. Those exist in here, so let's just cut those out and then go into our base magic character and add those into the protected section, then steal them away from our camera boom and our camera here as well, and add them into the constructor here too. We do need to add two include files here, which I'm also, again, we'll talk about that more in the next video. Probably should have made a video about that first, but I wanted to get into actual gameplay. We need to steal away the camera component, one here, and the spring arm component. So let's both of those, cut those out of this file and put those into this file. And then also just steal away these functions. We're not going to talk about those functions at all, really, in here, but we'll just put those into the public section here. This will allow us to use these functions to get top-down camera and get camera boom in any of the children, should we ever need. And now, when we open this up, we can see, in theory, anyway, somewhere around here, there's a camera boom. That one we're going to set to have 90 degrees of rotation, minus 90 degrees of rotation. So it's looking at us from the top. And also do make sure that our default pawn class is changed from BP top-down character into our BP player character. This one, because that's the one we've been working on. So now that we're looking at this from the top on, let's just take this as our base. And say from here we need to move up and down when we press the W and S keys, and left and right when we press the A and D keys, and obviously that's not what's happening right here. So the best way to just go about doing this is going into our top down, our inputs, and then change these input mappings to whatever they should be. So when we press the D key is when we're going up. So whatever D is doing right now, that should become W. And as you might imagine, that means that the A should become the S. The S should become the A, and the... which one is this? I think this should become the D. And now we can move around properly like you imagine. Still no animation, there's still no aiming or facing into different directions, but at least we've got the input right. This is the most fiddly thing to get right, and we can move around now. So everything after this is going to be remarkably much easier. We'll get back to adding some more input actions at a later date once I've explained a couple of things about the engine and coding a little bit more, and we'll be adding a system where we can use the arrow keys to change our direction and start firing bullets in whatever direction we might be pressing. And that will work in the exact same way that we have set up this, but we'll also be using a spawning in of actors, which we first need to make those bullet actors. So we'll get to that first. If you do think, hey, I have all the knowledge to make the implementation of the arrow keys to at least rotate the character around, do feel free to take on that challenge. You might have to look back at the video that we're going to do in the future and change a couple of things around. But hey, if you have a different implementation and it works, you know, if it works, it works. So next time we'll be back. This video has been long enough as is. I have no idea how long the final video is going to be because there was a lot of issues that I had to live debug, like me forgetting to put in that const, and then the whole camera situation was kind of troubling. So next time we'll be back talking a little bit more about those include files, because that's quite important to understand. And a very big thank you to all of my Patreons. You can see them on screen right now. If you want to help out supporting the channel, there's a link down below in the description to the Patreon page. And a special thanks to my Cave Digger tier Patreons, Sir J. Thomas and Eleanor.